So what about, rather than me saying, hey, solve for your zeros, what if I say, hey, your zeros are 7 and 2. Tell me what that polynomial is. All right? So let's go back exactly what Ronnie said. She said, well, if these are your zeros, right, before I listed zeros were equal to these numbers, I said, well, that meant the value of x equaled 7 and the value of x equaled 2. Right? The value of x equals 7, the value of x equals 2. Because remember, the zeros, when we look at solving by factoring, the zeros are your x-intercepts. Right? They're the value of x when your graph crosses the x-axis. So therefore, these zeros have a value of x. Does everybody understand that? Now, to write our polynomial, we're just going to work backwards from that last problem. So first we go to zeros, then we write them set equal to 0, and then what do you think the next step we're going to want to do? Set them equal. We want to write them as our factors. So how can we rewrite them as our factors? Yes, please. Close on there. Anybody have an idea? Yes. Right. Well, let's think about it. Remember, our zeros are when these are the x value, right? So if you think about it, these are the x values when your graph crosses the y or the x-intercept. So our value of y is equal to 0. So what we can say is we can now solve these or set these equal. We don't need really the parentheses right now. But what I'll do is, remember, because our last step, how did we get to even these values? We had them set equal to 0. And why do we have them set equal to 0? Well, because we had to go back and use the zero product property. But it also says when our factor is equal to 0, right, that's like our y value. Right? We want to say, all right, when the y value is equal to 0, what are the values of x? So we applied our zero product property. Now what I can do is I can write these as their factored form. Right? Because what we're trying to do when I say solve for an equation, when I say solve for x, what I'm trying to do is ask you, or find these zeros. What I'm doing is find the value of the function when your y value is equal to 0. When your y value equals 0, what is the value of x? We set them both equal to 0, and then we solve. So now if I say I already have them solved, that means you're going to write them as x, set them equal to 0, and then I can rewrite them going back using my zero product property. Now, can we multiply this out? Can we multiply that out? Yeah. Just to go ahead and apply your FOIL. You guys need me to do FOIL or the box? Okay. We'll do the FOIL. FOIL, first, outer, inner, last. So we do the f's. X times x equals x squared. Outer, x times negative 2 equals negative 2x. Inner, negative 7 times x equals negative 7x. Then we do last. Negative 7 times negative 2, which equals a positive 14. Then we notice our middle terms we can combine. So our final answer is x squared minus 9x plus 14. Now, when we were solving, I would set that equal to 0, right? Because that would be the first step. Oh, what are the values of x that make this equation equal to 0? Meaning, when would my graph cross the x-axis? Because y value is equal to 0 at that point. But ladies and gentlemen, they're not asking us to get just the polynomial equal to 0. They're saying, what is the polynomial? So we'll call our polynomial f of x equals. So therefore, the polynomial, when you have zeros, 7 and 2, is going to equal x squared minus 9x plus 14. Kind of make a little bit of sense? Huh? You were absolutely correct. Very good.